we have seen last class the Kirchhoff voltage law. Remember? Remember that in Kirchhoff voltage law, we analyzed the circuits utilizing loops or closed circuits. And we investigated all the voltage drops and voltage rises, which were almost equal to zero. And we are going to see the simile for current, which is called Kirchhoff current law. That I will share this slide. Says that all the currents that go to a loop must be equal to all the currents that leave that loop. So, the analysis is made not only for a junction. A junction is a node. Una junta es un nodo, que es el punto donde confluyen varias corrientes. Pueden ser corrientes que lleguen o que salgan, pero lo que nos está diciendo que la suma de las corrientes que llegan es igual a la suma de las corrientes que salen. Y se puede analizar también no solamente un nodo, sino también una región. For example, let's analyze this region. Let's make the input current sum. Which are the input? ¿Quién me puede decir quiénes son las corrientes de entrada a esta región?
La de la flecha para adentro, ¿no?
¿Pero qué números de corrientes?
4
y 1 y 4.
¿Ah? ¿La cual?
I4.
I1 e I4. ¿Y las corrientes que salen?
I2
y 3. Entonces, lo que nos dice la ley, que la suma de las que entran debe ser igual a la suma de las que salen. Entonces, sumemos 4 amperes más 8 amperes, ¿cuánto nos da?
12.
12. ¿Y cuánto nos da las que salen? 2 más 10. 12. O sea que está cumpliendo con eso. The sum of the currents entering a junction or region of a network must equal the sum of the currents leaving the same junction or region. Y por otro lado, dice que la suma algebraica de todas las corrientes que entran y salen de una junta o región de una red es 0. Esto se debe de escribir. Lo malo es que estoy compartiendo, no puedo. Well, in the next slide, I'll show it to you. And this is what says I1 plus I2 plus I3 plus I4 plus I5, whatever, will equal to 0. The same as in the voltage law, is all the voltages are equal to 0. In a loop, here, in a node, so in a node, the sum of all currents that enter and leave this node will be equal to 0. Déjeme. Allí. Yeah. Let's learn a convention. Currents entering a node are positive, and currents leaving a node are negative in the formula. In doing this, because this is an algebraic sum, you can sum 1 plus, let's say, plus menos 5, pueden ser sumas algebraicas de, por ejemplo, 6, más menos 5, más 7, etcétera, igual a 0. Okay? Then you can, let's go back to the exercise. This one. We can do the analysis. I4, we will put a positive sign here. And also for I1 and I4 are positive. And these two which are leaving are negative. So the equation will say 4 plus 8 minus 2 minus 10 equal to 0. Que es lo mismo que lo que hicimos aquí, pero rigurosamente la ley lo que dice la suma algebraica de las corrientes es igual a 0. Okay, let's do this example that is illustrated like a river that has several streams or affluents. We can see here that we have 5 currents. I1 is coming into node A. So we'll put here a positive sign. Okay. I2 also is coming into the node A, and we put also the positive sign. I3 is leaving node A, so we'll put here a negative sign, and then we can do the analysis for node A. Well, I have already done this in the last class. Then plus 2 amperes, plus 3 amperes here, plus minus I3 equals 0. Where we solve for I3, we say that 2 plus 3 is 5 equals I3. So I3 equals 5 amps. Okay? We resolve this first question. Now let's analyze the node B. Note that for node B, the same current I3, in this case, it is an incoming current because it's going into the node. So in this case, it's positive. Then I4 is leaving the node. So because it's leaving the node, you put here the negative sign. And I5 is coming into node B, and that is positive. So we go to the equation and we do the summation. We have here I3, but we know that I3 is 5 amps, which was calculated. So we put here 5 amps plus 1 amp, that is I5, minus I4, because it's leaving, minus I4 equals 0. So we resolve to 6 So I4 equals, say, 6 amps. Okay? Did you follow me at your notebooks? Okay. Now, let's analyze. Remember, in the beginning, we said that we can analyze a node or a region. In this case, I have drawn this arbitrary, ¿cómo se llama? Frontier, and we can analyze what comes in and what goes out. In this case, we can see that into the region, into the border, let's say, is I2, also I1, I4 is leaving, so we'll have also this negative sign, and I5 is positive because it's coming into the border. While here, I3, we don't take it into account because it is inside the frontier. It's not entering nor leaving. He's inside, so we are only analyzing this data go to the border. So in the region, we will analyze the summation of input currents that must be equal to the summation of output currents. Sorry for my letter here, this is an I with a little zero there. Perdón por mi letra, esta es una sigma por I O de salida. So we can start from this point, and we have plus 1 ampere here, plus 3 amperes here, and plus 2 amperes. That's the incoming, and that will be equal to the outgoing, which is only 1 I4. This must be equal to I4. We do the addition. 2 and 1, 3, and 3 makes 6. 6 amperes equals I4. That it is our result. Okay. Now, let's analyze this circuit. In the beginning of the analysis, I had drawn this. Let me erase. We have here a question mark, an interrogation. That is, we don't know I3. Okay. In the beginning, we can put the arrows. If we know that these 10 amperes come into the node, that this I2 is leaving the node, and this I3, we don't know. We just put arbitrarily this direction, but can be or can be the opposite. Okay? So let's do the analysis, which is very simple. First, then you tell me. Oh, no, sorry. here, this is I1 is incoming to the node. We put a positive sign here. I3, we don't know. I put that. But I2 is outgoing, so I put here a minus sign. Okay? So I go to the equation and put it here. It's already done. Go to this equation, 1, 2 plus 1, 2 plus 1, 2 equals 0. So I1 is plus 10 amps. I2 is minus 4 amps plus I3 equals 0. 10 minus 4 equals 6 plus I3 equals 0. So I3 equals minus 6 amps. So because this is negative, which means this current is leaving the node. Lo que significa que esta corriente está saliendo del nodo. Entonces vamos a ponerlo. So this assumption was wrong. We cancel this, and the correct direction is 6 amps. Okay. Okay. Let's make another exercise. It's already solved. In this case, we have 4 currents. I1 is outgoing, so we'll have a negative sign. I4 is, let me see. We don't know yet. We only know that this is an incognite. I2 is positive because it's incoming to the node. And also, I3 is positive because it's incoming, is coming into the node. Ok, aquí ya lo tenía, el más. Then we can do the summation of currents equals 0, which means 1, 2 plus I2 plus I3 plus I4 equals 0. Okay? Utilizing the convention, we will have here, this is different. We will have here this negative 8 amps. I omit here the amps. Negative amps plus positive 9 amps plus positive 7 amps plus I4. We don't know I4, what it is, the incognite. So we can make this summation. Minus 8 plus 9 equals plus 9. Plus 1, I mean, plus 1. Plus 7 makes plus 8. Plus 8 plus I4 equals 0. If we take this 8 to the right side of the equation, it will be negative. So I4 equals minus 8 amperes. And because it is negative, means that it's going to be leaving the node. So that's what I had erased it. It's leaving. And it will be 8. Okay. We don't put here the negative sign. The negative sign is just for the equation. And we obtain the result. And this minus 8 amps means that this 8 amps go to the north, go leaving the node. Now, let's do the other equation. The sum the summation of input currents equals summation of output currents. Okay? So, which are the incoming currents? Are I3 and I2, which we put 1,3 plus I2. That will be equal to the outgoing currents. You know, which are the outgoing currents? Are I4, this is this one, and I1, I4, this is supposed to be a 4, and this is a number 1. And substituting the values, 7 amps plus 9 amps equals 8 amps here plus 8 amps here. So it will give us 16 the right side, and in the left side, guess what? It's also 16. 7 and 9 is 16. So 16 equals 16. Okay. Okay. Now let's go to see the homework. Okay. Can you see this? I'm sorry for the handwriting. In this case, we have the first problem is here. This is the second problem. This is the third problem. And the fourth. The first is actually it's a serial circuit, but there is the first question to obtain the voltage between these points A and B. And we denote this as VAB, put it positive because it is more positive than here. So VAB, and there is also an interrogation here on V1. We also want to know the value of V1. Later, we have to observe the polarization of the resistors. They are plus, minus, plus, minus, plus, minus, which means that in this case, all three are voltage drops, okay? So that has a meaning on the direction of the current, which is the direction of the current here, clockwise, or counter, no, clockwise or counterclockwise. That's what you have to indicate. The second problem is the one that we have just made. So if you put attention, you will have no problem to solve it. If you took notes, that's better, then you will copy your notes. Exactly the same. We don't have the direction for I4, we have to find that. Then we have the third. In this case, we have 5 branches and 5 currents. I1 is incoming. So you will know we have to put a positive or negative sign. Current I2 is outgoing, so it is also you will put the corresponding sign. I3 is a question mark. We don't know I3. I5 is 20 amps going into the node, going to the node. So you put the sign. And I4, we don't know, it's also an incognito, but we know that it equals 2 times I3. So you have to do a similar analysis to that one and obtain the values. When you obtain I3, you will obtain I4 because it's only the double. Okay? So the last part of the homework, which is going to be for Friday, is a list. Make a list, a notebook of the Greek alphabet and the names, well, lower and upper cases, an equivalent Latin letter, you know, and also the names of the letter in Greek. For example, here is a column, here, column, there's another column, Aquí Fab. Latin. We have a Latin alphabet. And then you make this. Me quedó muy pegado y no lo pude trazar bien. Hacen con todas las letras para que las conozcan y se aprendan las principales. Ahí va a venir la mu, ahí va a venir la sigma, la omega, ¿ok? La omega, que por ejemplo para el movimiento angular es como una especie de W, pero no es W, es una omega minúscula, ¿ok? Bueno, entonces esta es la tarea. Y se las voy a pegar en la página de... Ahora, bien, ya nada más voy a checar, a ver si alguien más llegó. Y ya damos por terminada la clase. Cepeda García Adrián.
Presente.
¿Acabas de llegar ahorita o qué?
No, me metí al principio de la clase, pero ya me había pasado.
Ok. Garrido Castro Joel. ¿No está?